instruments that have allowed us to locate other solar systems are relatively recent innovations. The question of whether there are other solar systems has fascinated humans for thousands of years. Instead of employing scientific terminology, the debate on this issue has mostly centered on philosophical or even theological grounds for most recorded history. As the quotations demonstrate, two opposing schools of thought from antiquity believed that other worlds similar to Earth might exist, while one believed they couldn't. It is important to remember that modern science requires testable hypotheses. Science distinguishes itself from other intellectual endeavors by constantly testing theories against the laws of nature. Therefore, for most of history, exoplanet hunting was not a science. However, the search for other planets has been the subject of some of the greatest minds the human race has ever produced. And some of the questions these discussions raise hint at problems that scientists are still debating today. First, let's talk about the Greeks. To comprehend what historian Stephen Dick refers to as the plurality of worlds, which the Greeks sought, we must first understand how they viewed their universe. The fact that immobile and unmoving Earth sat at the center of creation was undeniable to them. The sun, the moon, the planets, and the stars in the outermost crystal sphere all revolved around Earth in a sequence of concentric crystal spheres. The Greeks, therefore, referred to other groups of concentric crystal spheres, each centered on its own central, immovable Earth, when they discussed other worlds. In their own language, they were talking about the existence of cosmoi, another complete universe. More than a search for other planetary systems, the Greeks' argument over the existence of such cosmos mirrored the conflict over the existence of other galaxies in the early 20th century, as we have already noted, with two opposing and sharply divided schools of thought. Since it dominated the thinking of ancient and medieval scholars, the school linked to Aristotle's writings was by far the most significant. In contemporary parlance, we would say that Aristotle's conclusions were grounded in his physics. For an Aristotelian, the world comprised four elements: fire, air, water, and the well-known earth. Everyone had a natural tendency to look for a specific location in the cosmos. A fire-based object would gravitate toward the universe's periphery, but an Aristotelian would see the center of the universe as being the same as the center of the earth. Therefore, if left to their own devices, fire-related objects would rise, and earth-related objects would fall. It's crucial to keep in mind that an Aristotelian observing a rock fall would perceive an expression of the rock's nature rather than the action of gravity as we do. Like a salmon swimming upstream, the rock is forced to return to its spawning location by forces it cannot understand. In light of this physics, it is easy to understand why Aristotle disapproved of the idea of other worlds. How would a rock locate the center of the earth if there were several? How would it know which way to fall? Aristotle had to deny the existence of other Earths to escape this conundrum. The atomist perspective, which was a minority opinion for the majority of history, was the opposing viewpoint to Aristotle. According to their theory, the universe was made up of an endless number of atoms. The word's Greek root, atomos, means that which cannot be divided, separated by voids. The atoms were constantly changing, and the familiar universe was the product of a group of them coming together more or less by accident. Echoing current discussions about extraterrestrial intelligence, the atomists argued that atoms must repeatedly come together in an infinite universe. As a result, multiple worlds had to exist. Since neither side offered any verifiable claims, we stress again that these old arguments were not scientific in the contemporary sense. However, They shaped the discourse when it reappeared in medieval Europe. Greek knowledge arrived in Europe roundaboutly, with works translated into Arabic at locations like the House of Wisdom in Baghdad, and then into Latin at locations like Toledo, Spain, following the Crusades. Around 1170, Aristotle's primary cosmological work, De Caelo, The Heavens, was swiftly adopted into the curricula of the newly established universities in Oxford and Paris. Thus, in his great effort to bring faith and reason together, Thomas Aquinas, 1224–74, approached the issue of the plurality of worlds with a strong influence from Aristotelian physics. Aquinas essentially argued from the unity of God to the unity of God's creation, adding a Christian gloss to Aristotle's arguments against the existence of other worlds. However, this argument soon encountered theological issues. Theologians essentially contended that it cast doubt on God's omnipotence and curtailed his power. Etienne Tempier, the Bishop of Paris, reportedly produced a list of 219 beliefs that were to be deemed heretical in 1277, ostensibly at the request of Pope John XXIII. One idea in this list, the Condemnations of Paris, was that the first cause cannot make many worlds. Item 34. Item 34 contends that claiming that God is incapable of creating other worlds would be a limitation on his power and would be heretical since the first cause alludes to God. The list appears to have developed from a dispute between the University of Paris's theologians and its more liberal arts faculty, which focused on the latter group's fervent adoption of the new Aristotelian knowledge. Either way, it changed the plurality of worlds argument by requiring new methods of understanding Aristotelian physics to avoid clashes with church authorities. William of Ockham, 1280–1347, a philosopher best known for creating the theory of Occam's razor, which maintains that the simplest answer is usually the right one, was the first to do this. He disproved the Aristotelian argument by claiming that the four elements' fundamental properties are constant, but that their expression varies based on the location. He used two fires as examples, one in Oxford and one in Paris. Because of their inherent characteristics, fires would seek out distinct locations on the universe's edge, one above Oxford and one above Paris. But if you switch the two fires' locations, the Paris fire will try to find a spot above Oxford, and vice versa. Similarly, something composed of earth might look for the center of a different world instead of our own. One remarkable feature of this lengthy history of debates regarding the plurality of worlds is that nobody ever considered the possibility that any of these multiple worlds were home to living things. This issue wasn't brought up until the 15th century by Nicholas of Cusa, 1401–64, a German theologian and churchman. Rather than think that so many stars and parts of the heavens are uninhabited, he said, we will suppose, in many regions, there are inhabitants. Giordano Bruno, 1548–1600, arguably the most well-known of the early proponents of the multiple world picture, included this idea in his cosmology. More than anyone else, Bruno advanced Copernicus' theories by claiming that other stars, like our sun, had their own planetary systems, possibly with life on them. As a nonconformist, Bruno promoted several ideas that ran counter to the Church's teachings, such as the denial of the Trinity, the divinity of Christ, and the idea of transubstantiation. His trial for heresy was based on these theological beliefs rather than his cosmology. He was burned at the stake as a heretic in 1600 because of his beliefs. Serious theological issues soon arose after Nicholas of Cusa first proposed the possibility of extraterrestrial life. Martin Luther's collaborator, the Protestant theologian Philip Melanchthon, 1497 and 1560, maintained that the theological problems raised by the concept of multiple worlds forced us to reject it. Two significant events form the foundation of Christian doctrine: Catholic, Protestant, and Orthodox. The redemption, the crucifixion and resurrection of a Jesus, and the fall, the expulsion of Adam and Eve from the Garden of Eden. The existence of extraterrestrial life is a topic of discussion in the relatively new field of exotheology. Did the fall, for instance, happen to all races and on all planets? If not, did beings who had never been in the fall need to be redeemed? Did Jesus have to go to every world to die and rise? Or were the events on Earth enough to cover everyone if the fall was universal? Why is Earth so central, if so? In other words, is there another way to be saved? It's easy to see how this theological inquiry could continue indefinitely. There have been some historical precedents for handling issues related to alien life. For example, Native Americans likely appeared alien to European explorers, as an alien world to us when they first came into contact with humans in the Western Hemisphere. Pope Paul III declared in his 1537 edict, Sublimus Dei, that the people of the Americas had souls and ought to be baptized and converted to Christianity. Pope Francis recently declared that he would baptize a Martian if the chance arose, bringing this tradition of acceptance into the present era. The plurality of worlds argument underwent another shift with the Enlightenment and the emergence of modern science. Prominent thinkers like Christian Huygens and René Descartes, 1596 to 1650, published cosmologies that clearly depicted planets orbiting other stars. Like the Greeks and medieval philosophers, their theories were based on recently discovered physical principles and spoke to the modern ear, even though they lacked observational validation. Philosophers and scientists debated whether life existed on the moon, speculating about the possibility of exoplanets and alien life. However, technological developments did not make it possible to move this problem from philosophy to observational astronomy until the middle of the 20th century. Now, let's talk about why finding exoplanets is so hard. The distance to another star, 61 Cygni, which is 10.9 light-years away, was not measured until 1838 by the German astronomer Friedrich Bessel, 1784-1848. The size of the Milky Way and the astounding separations between stellar systems became clear to scientists for the first time. For comparison, Alpha Centauri, the closest star, would be situated in the center of Russia if we cut the distance between Earth and the Moon to just 1 foot. As a result, we are looking for comparatively small objects that are far away, which is never easy. Furthermore, planets are far away and very dim because they only shine through reflection, whereas stars produce their own light. One author likened the challenge of locating them to the challenge of using a telescope in Washington to spot a birthday candle at the edge of a searchlight in Boston. DC. However, in a scenario such as this, the planet's obscurity is not the primary issue. Far fainter objects in the sky have been picked up by the Hubble telescope. The issue is the planet's proximity to its star, a massive light source. Distinguishing a planet's reflected light from its star's glare is especially difficult. Due to these two challenges, scientists started looking for exoplanets in the 20th century by examining how the planets affected their parent stars rather than the planets themselves. To better understand the developed techniques, picture yourself as an astronomer on a planet orbiting a far-off star, attempting to find planets in our solar system. The common description of our solar system is that the planets orbit the sun. This isn't an exact description, though. because the Sun and a planet like Jupiter orbit a point known as the center of mass. Since Jupiter is the largest planet and has the biggest impact